August 14, 1942, the Detroit Tank Arsenal, Warren, Michigan. Inside the cavernous factory, a cathedral of steel and noise, plant manager John Caden stood with a stopwatch in hand. His gaze was fixed on hull number 217. Around the embryonic tank, workers moved with the methodical precision of a trained orchestra, their every action dictated by the thick technical manuals issued by Army ordnance. Every weld was a work of art, meeting exacting inspection standards. Every bolt was torqued to specification. The problem wasn't the men, the problem was the clock. Hull 217 had been on the assembly floor for 11 days. According to the current production schedule, it would require another 8 before it could be considered a complete M4 Sherman medium tank. 19 days for a single machine. At that rate, the Detroit Tank Arsenal, the largest, most modern tank factory in the world, a symbol of American industrial might, would produce approximately 420 tanks annually. The United States Army had requisitioned 10,000 for 1943 alone. A simple, chilling calculation revealed the truth. To fulfill a single year's order, this factory would need 24 years. The mathematics of defeat were being written in man-hours and assembly time, a grim equation unfolding largely unnoticed by management. But off to the side, leaning against a steel girder, a 47-year-old civilian consultant named Charles Sorensen was making his own calculations on the back of a requisition form. Sorensen, who had spent 36 years at Ford Motor Company revolutionizing automobile assembly, watched the scene with the dawning horror of a master craftsman witnessing sacrilege. What he saw violated every principle of efficient manufacturing he had spent his life perfecting. Tanks were being built like bespoke locomotives, with crews swarming around a stationary vehicle to install components one by one. It was artisanship applied to industrial warfare. It was impossibly, criminally, slow. Sorensen's pencil-scrawled figures suggested that, with the proper application of continuous flow principles, the assembly time could be slashed from 19 days to just 48 hours. When he later hinted at this, his colleagues thought he was insane. Army ordnance officials declared it impossible. Tanks are not automobiles, they insisted, a mantra repeated to shut down any debate. The complexity, the precision, the sheer weight, all, they argued, demanded the methodical, glacial pace currently in place. But Charles Sorensen was about to prove them all wrong. His impossible trick, applying the logic of the assembly line to the art of tank building, was poised to transform American armored warfare from a craft into an industrial hurricane. Within 18 months, this very factory would be rolling a complete Sherman tank off the line every 60 minutes, 24 hours a day, 7 days a week. This is the story of how one civilian's manufacturing revolution forged the avalanche of steel that would bury the Wehrmacht. To understand the miracle that was about to unfold, one must first understand Charles Sorensen. He was not a soldier, a strategist, or a weapons designer. He was a force of nature cloaked in a civilian suit, a high priest of production. For 36 years, he had been Henry Ford's iron-willed right-hand man, the brutal but brilliant genius who had taken Ford's abstract vision and hammered it into the world-changing reality of the moving assembly line. It was Sorensen who had orchestrated the industrial ballet that cut the Model T's assembly time from 12 hours to 93 minutes, effectively putting a nation on wheels. His masterpiece was the River Rouge plant, a city-sized behemoth that inhaled iron ore and coal at one end and exhaled finished automobiles at the other. He had retired in 1941 after a bitter falling out with Henry Ford's son, Edsel. But for Sorensen, a Danish immigrant who saw his own life as a testament to American opportunity, watching the world plunge into war from the sidelines felt like a betrayal. His personal mission and the nation's survival had become one and the same. When the War Production Board asked him to consult on the sputtering tank program for a symbolic $1-a-year salary, he accepted immediately. The title of consultant was a quiet understatement. Sorensen arrived with the authority of a man who had built the modern industrial world. His expertise was not in armor plate or turret rings, but in the relentless, unforgiving logic of motion. He saw waste, wasted steps, wasted time, wasted effort as a moral failing. He believed that any complex process could be broken down into a series of simple, repeatable tasks, and that this division of labor was the key to unlocking unimaginable productivity. This was the gospel of Ford, and Sorensen was its most fervent apostle. He looked at the M4 Sherman not as a mystical beast of war, but as a product. A complicated product, to be sure, but a product nonetheless. And any product, he believed, could be made efficiently. It was a perspective so simple it was revolutionary, and it put him on a direct collision course with the rigid, tradition-bound culture of the Army Ordnance Corps, who believed that the art of war could never be subjected to the crude logic of the factory floor. They were about to learn that in a total war, the factory floor was the battlefield. Sorensen's first week at the Detroit Tank Arsenal was a descent into a production engineer's hell. The vast factory floor, which should have been a symphony of synchronized motion, was a discordant mess of starts and stops. He watched as teams of workers, electricians, welders, mechanics, crawled over and around stationary hulls, a ballet of wasted motion. They would finish one task, then wait. Wait for the next crew, wait for a specific tool, wait for an inspector to sign off on their work. The tank, the most vital weapon of the ground war, was being built with the patient, unhurried methods of a medieval guild. Armed with a stopwatch and a clipboard, Sorensen conducted his own unauthorized time and motion study, a practice he had perfected over decades at Ford. He wasn't just timing the work, he was timing the waiting. And the waiting, he quickly realized, was the true enemy. The 19-day assembly schedule wasn't a measure of labor, it was a measure of inefficiency. His calculations were swift, brutal, and utterly clear. The actual wrench time was a fraction of the total. The rest was dead air, a colossal waste of the nation's most precious resource: time. After 2 weeks of quiet observation and furious calculation, he had identified 173 distinct operations required to build a Sherman tank. His analysis was simple and damning. It didn't need to take 19 days. With the right organization, it could be done in 48 hours. He began to sketch out his heretical idea, not just on paper, but in his mind's eye. He envisioned the tank hulls not sitting idle, but moving relentlessly forward on a heavy-duty conveyor, gliding past a series of specialized workstations. At each station, a small expert crew would perform a single repetitive task: installing the suspension, mounting the engine, fitting the turret, with all the necessary tools and parts waiting for them. No wasted steps, no waiting, just pure, continuous flow. It was the logic of the slaughterhouse disassembly lines that had inspired Ford decades earlier, but applied in reverse and scaled for 15-ton machines. It was the system that had built the River Rouge plant, the most efficient manufacturing engine the world had ever seen, and it was the idea that would ignite a firestorm of opposition. When Sorensen presented his proposal to Chrysler management and the Army Ordnance representatives in August 1942, the reaction was not just skepticism, it was visceral, bordering on hostile. The room, filled with the nation's top automotive engineers and military procurement officers, went cold. Sorensen, with his simple diagrams and confident assertions, was speaking a language they refused to understand. Brigadier General James W. Wesson, the imperious chief of Army Ordnance, dismissed the idea out of hand. His voice dripped with the condescension of a man whose authority had been questioned by an outsider. "Mr. Sorensen," he stated flatly, "tanks are not automobiles. They cannot be built like automobiles." It was the definitive, unchallengeable judgment of the military establishment. Chrysler's own engineering staff, men who had been tasked with the impossible job of running this new arsenal, quickly fell in line behind the general. They saw Sorensen not as a savior, but as a disruptive force, a Ford man telling them how to do their jobs. They flooded the discussion with a barrage of technical obstacles, each presented as an insurmountable peak. "A tank hull weighs 15 tons, one engineer argued. "Your standard conveyors would buckle instantly." "The turret installation requires massive overhead cranes," another added. "You can't operate those over a moving line without disaster." The final drive assembly involves components weighing over a ton each. The precision required is immense. Welded hull construction demands a stationary platform for proper heat penetration and cooling. The integrity of the armor is paramount. For every problem, Sorensen had a counter. Heavy-duty conveyors from locomotive shops, mobile gantry cranes that moved with the line, pre-positioned components and dedicated lifting equipment, brief pauses at specialized welding stations. He parried every thrust with a specific, practical solution drawn from his deep well of experience. But he wasn't just fighting technical objections, he was fighting a mindset. He was fighting the ingrained belief that military hardware was somehow sacred, exempt from the laws of industrial efficiency. The debate raged through August and into September. Army ordnance dug in its heels, citing regulations and inspection protocols that were fundamentally incompatible with a moving line. Chrysler's management, caught between a demanding military customer and this stubborn consultant, grew anxious about the massive disruption a change would cause. They were producing tanks, albeit slowly. A factory-wide reorganization could halt production entirely, a risk they were unwilling to take. The wall of no seemed impenetrable. Charles Sorensen, the man who had bent steel and men to his will for 40 years, was on the verge of being thanked for his time and politely shown the door. Backed into a corner, with his reputation on the line, Charles Sorensen played his final card. It was a move born of sheer, bloody-minded confidence. "Give me a corner of the factory," he proposed, his voice cutting through the stale arguments. "Give me a space to build just 3 tanks. If my methods can produce 3 tanks faster than your traditional line can produce 1, you will authorize a full-scale implementation. If I fail, I will walk away." It was a classic industrial wager, a put-up or shut-up challenge that even the most stubborn bureaucrat couldn't easily refuse. Reluctantly, Chrysler management and Army ordnance agreed. The demonstration would take place in Sector D, a cavernous area previously used for sub-assembly work. The clock started on October 1st, 1942. Sorensen had 3 weeks to build a revolution from scratch. The challenge was monumental. This wasn't a matter of rearranging a few workbenches. He needed custom-built conveyors that could bear the weight of a 15-ton hull, specialized tooling positioned for continuous access, and a material handling system capable of delivering components weighing thousands of pounds to the exact point they were needed, at the exact moment they were needed. Sorensen became a whirlwind of focused energy. He brought in his old guard, the best and brightest from Ford's legendary River Rouge plant, men who understood his vision implicitly, who had helped him tame the chaos of mass production before. They were masters of the impossible. They designed hydraulic lift systems, custom roller conveyors with reinforced load bearings, and overhead delivery tracks for smaller parts. They even developed automated welding fixtures that could hold the massive hulls in a perfect embrace, ensuring flawless welds every time. The prototype line snaked for 180 feet, a miniature version of Sorensen's grand vision. It consisted of 11 primary workstations, each meticulously timed. Every operation, from the initial hull welding to the final systems check, was designed to take exactly 12 minutes. It was a clockwork universe built for a single purpose: to prove the naysayers wrong. As the final pieces of the line were bolted into place, a palpable tension filled Sector D. The experiment was about to begin. The first trial run began on October 23rd. The mood in Sector D was electric. Sorensen's men, a mix of Ford veterans and retrained Chrysler workers, took their places. The Army Ordnance observers stood with their arms crossed, their faces masks of skepticism. The first hull, a massive 15-ton block of steel, was lowered onto the conveyor. The line began to move, and almost immediately, it fell apart. The results were not just disappointing, they were catastrophic. The custom conveyors, designed to handle immense weight, groaned and jammed under the stress, bringing the entire line to a shuddering halt. The precision welding fixtures, so elegant on the blueprint, failed to align the heavy steel plates correctly. Workers, trained for decades in the art of moving around a stationary object, found themselves clumsy and disoriented, unable to adapt to the relentless rhythm of the moving line. Timing synchronization, the very heart of the system, collapsed into chaos. Some stations finished their tasks in minutes, while others took hours, creating massive bottlenecks and turning the smooth, theoretical flow into a stuttering start-and-stop nightmare. The Army observers watched the disaster unfold with a grim sense of vindication. This was exactly what they had predicted. The chaos was proof that tanks were not cars, and that this mad experiment was a dangerous waste of time and resources. They formally declared the project a failure and demanded that Sorensen abandon it immediately. Chrysler's management, rattled by the public failure and terrified of further production delays, agreed. The pressure on Sorensen was immense. The ultimatum had been delivered: return to the proven, traditional methods, or be removed from the project entirely. For any other man, it would have been the end. But Sorensen was not any other man. He had faced this kind of failure before. He remembered the disastrous early days of the Model T assembly line in 1913, when belts snapped, parts didn't fit, and the entire system seemed on the verge of collapse. He knew that initial failure didn't prove impossibility. It simply revealed specific problems that required specific solutions. With ice in his veins, he looked the generals and executives in the eye and refused. He had seen enough to know he was right. All he needed was more time. He requested 2 more weeks to refine the system, a plea that was met with open hostility. It was a career-defining moment of defiance. The next 14 days were a blur of furious improvisation. Sector D became a self-contained universe of controlled chaos, fueled by coffee, grit, and Sorensen's unyielding presence. He was everywhere at once, a ghost in the machine, climbing over conveyors, arguing with engineers, and sketching modifications on greasy pieces of cardboard. Engineers, working around the clock, redesigned the conveyor supports, distributing the load with reinforced structures that could now handle the immense weight. The welding fixtures were stripped down and rebuilt, their geometry modified not from the pristine blueprints, but from the actual, imperfect dimensions of the tank hulls themselves. Sorensen ordered an intensive retraining program for the workers, pulling them away from general assembly knowledge and drilling them relentlessly on the specific, repetitive tasks of their assigned station. The line's rhythm was rebalanced, its 12-minute cycle times adjusted by splitting some operations and combining others, all in a desperate search for a smoother flow. The second trial run, which began on November 9th, was a marked improvement. The tanks now moved, albeit with frequent frustrating stops, as new problems emerged and were solved on the fly. The team managed to assemble 3 tanks in 8 days, a significant victory over the traditional 19-day method, but still a far cry from Sorensen's audacious 2-day promise. It was better, but it wasn't the revolution he had envisioned. The breakthrough came on November 16th, a stroke of genius born from desperation. Watching the small delays accumulate as crews waited for one station to finish before the next could begin, Sorensen realized his core concept was still flawed. He had made the product move, but the workers were still stationary. He decided to invert the logic one final time. He implemented his most radical innovation, the moving crew concept. Instead of workers remaining at fixed stations, small, specialized teams would now move with the tank down the line, performing their operations as the hull crept slowly forward. It was a simple change with profound implications. It eliminated the dead time of station-to-station transfer, transforming the line from a series of linked sprints into a single, continuous marathon. It was the final, crucial piece of the puzzle. Now, everything hinged on one last trial. The third and final trial run began on November 23rd, the week of Thanksgiving. The atmosphere in Sector D was thick with a tension that was part desperation, part defiant hope. Sorensen had bet his entire reputation on this last attempt. Failure now would not just be embarrassing, it would mean his banishment from the war effort, the final, humiliating victory for the forces of institutional inertia. The first hull began its slow, deliberate journey down the 180-foot line. But this time, something was different. The stuttering chaos of the previous runs was gone, replaced by a strange, new, and powerful rhythm. Small, specialized crews, looking like choreographed dance troupes, moved with the hull, swarming it, performing their tasks with practiced efficiency, then peeling off as the next crew took their place. The tank never stopped moving. The Army Ordnance observers and Chrysler executives watched in stunned silence. They saw the suspension system mounted and the hull floor installed while the tank was in motion. They saw the massive engine and cooling systems lowered into place as the hull crept forward. They saw the completed turret, delivered from a parallel sub-assembly line, mated perfectly with the hull in a single fluid operation. The process was relentless, seamless, and hypnotic. The results, when they were tallied, exceeded even Sorensen's most optimistic projections. 3 complete M4 Sherman tanks, fully assembled, tested, and ready for combat, rolled off the prototype line in just 41 hours. An average of less than 17 hours per tank compared to the 456 hours required by traditional methods. It was a staggering 96.3% reduction in assembly time. More impressively, the quality of the tanks was flawless. Inspection teams, who pored over every weld and every bolt expecting to find evidence of rushed, shoddy work, found none. The armor passed ultrasonic inspection. The engines roared to life without a hitch. The test drives were perfect. These were not just assembled tanks. They were combat-ready war machines. Brigadier General Wesson, the man who had most adamantly declared the entire concept impossible, personally inspected all 3 tanks. He walked around them, climbed inside them, and ran his hands over the pristine welds. The evidence was irrefutable. What he had witnessed was not a trick. It was a revolution. Visibly stunned, he turned to Sorensen, the civilian consultant he had tried to dismiss, and gave the order that would change the course of the war: immediate, full-scale implementation across the entire Detroit tank arsenal. The impossible had just become official military doctrine. The transition to full-scale continuous flow assembly began on December 1st, 1942. Winning the argument was one thing. Winning the war of implementation was another challenge entirely. The scale of the task was staggering. The entire factory floor, 1.6 million square feet of it, had to be completely gutted and reorganized. Traditional workstations had to be dismantled, miles of new heavy-duty assembly lines installed, 40,000 workers retrained in a new philosophy of work, and the entire supply chain re-engineered to feed the ravenous appetite of a moving line, all while maintaining minimum production to meet the Army's desperate, ongoing needs. It was like performing open-heart surgery on a patient while he was running a marathon. Sorensen, a master of industrial logistics, devised a brilliant strategy. He divided the colossal factory into 4 parallel assembly lines, each capable of operating independently. This created crucial redundancy. A breakdown on one line wouldn't paralyze the entire plant. More importantly, it allowed for a phased transition. While lines A, B, and C continued to build tanks using the old, slow methods, Line D, the site of the original experiment, was the first to be fully converted. The work was relentless. Teams swarmed the factory floor day and night, tearing out old infrastructure and laying the foundations for the new system. The air was thick with the screech of metal and the shouts of foremen. Sorensen was the calm eye of the storm, his presence a constant source of pressure and direction. On January 7, 1943, Line A began its continuous flow operation. The initial pace was cautious, a tank rolling off the line every 8 hours. But as workers, now drilled in their specialized tasks, gained confidence and engineers smoothed out the remaining kinks, the tempo quickened. By the end of January, Line A was producing a tank every 4 hours, 6 per day. Line B converted on February 15th. Line C followed on March 1st. Line D, the last holdout of the old ways, began its continuous flow operation on March 22nd. By April 1st, 1943, less than 4 months after the reorganization began, all 4 lines were operating simultaneously. The factory, which had struggled to produce 3 tanks a day, was now producing 24. The avalanche was beginning to build. 24 tanks a day was a staggering improvement, but for Charles Sorensen, it was only the beginning. His original calculations had pointed to a cycle time of 1 hour per tank, and he was a man obsessed with achieving theoretical perfection. The current 4-hour cycle, while miraculous to everyone else, was to him a sign of lingering inefficiency. He began a relentless hunt for the remaining bottlenecks. The primary culprit was turret installation. Lowering the heavy, complex turret onto the hull required a level of precision that forced the line to slow to a crawl. Sorensen's team designed a specialized turret mating station where the hull would pause briefly. Here, mechanically assisted robotic arms, a marvel of 1940s engineering, could lower and secure the turret with extraordinary precision in just 6 minutes, eliminating a 30-minute bottleneck. Next came the engine. The 1,150-pound Reich R975 radial engine had to be perfectly aligned with the transmission and cooling systems. Sorensen's solution was an automated engine dolly that traveled alongside the moving hull, allowing the installation crew to work continuously as the tank crept forward. Similar innovations were developed for the heavy final drive and transmission units, using mobile, floor-mounted lifts that tracked with the line. These refinements were implemented through April and May of 1943. The results were immediate and dramatic. By June 1st, the cycle time had dropped to 90 minutes per tank. By the end of June, it was 75. And on July 31st, 1943, the factory achieved Sorensen's impossible goal, a cycle time of 63 minutes, slightly faster than 1 tank per hour. The transformation was complete. The Detroit tank arsenal, which had produced just 12 tanks in April 1942, produced 721 tanks in July 1943, a 60-fold increase in 14 months. The numbers behind the numbers were even more mind-boggling. The man-hours required per tank plummeted from 456 to just 48, a 950% increase in labor efficiency. Defect rates dropped by 73%, as specialized workers became masters of their single, repeated tasks. The impact rippled across the nation. Sorensen's methods were immediately adopted by other tank manufacturers, from Fisher Body in Michigan to Pacific Car and Foundry in Washington. By the end of 1943, American factories were churning out 2,100 Sherman tanks every month, a tidal wave of steel that German intelligence, still basing their estimates on traditional manufacturing rates, believed to be impossible. The avalanche had been unleashed, and it was about to crash down on the battlefields of Europe. The story of the Detroit tank arsenal was not just one of steel and machinery, it was a story of people. At its peak, the factory employed 40,000 workers, a city within a city dedicated to a single purpose. Under the old methods, this massive workforce would have been lucky to produce 800 tanks a year. Under Sorensen's system, they produced over 8,000, a tenfold increase in labor productivity. This was not achieved by forcing people to work harder or longer. In fact, workers on the new continuous flow lines reported less physical strain than before. The genius of the system was in its elimination of wasted effort. No more time spent hunting for tools, carrying heavy components, or waiting for the previous operation to finish. At a specialized station, every movement was productive, every action part of a greater rhythm. The change was also a social revolution. The urgent need for labor broke down barriers that had stood for generations. The iconic image of Rosie the Riveter came to life as women, previously excluded from skilled industrial jobs, proved they could build tanks with the best of them. African Americans and other minority groups, long denied opportunities, found a foothold in the war industries, proving their capability and helping to crack the foundations of systemic discrimination. The transformation radiated outward. Warren, Michigan, a quiet rural township of 10,000, exploded into an industrial metropolis of 50,000 in just 2 years. New housing, schools, and hospitals sprang up to support the workforce. The entire Detroit metropolitan area became the undisputed arsenal of democracy, the industrial heart of the Allied war effort. There was a profound psychological impact as well. Watching a completed, battle-ready tank roll off the line every hour instead of every few weeks provided a tangible sense of contribution to the war. Union representatives, initially suspicious of the changes, became enthusiastic supporters as they saw the tangible results and the improved working conditions. Ordinary people, most with no prior manufacturing experience, were achieving extraordinary things. Sorensen's system hadn't just made the work more efficient, it had democratized industrial expertise itself, proving that, with the right organization, anyone could help build the arsenal of victory. The legacy of Charles Sorensen's revolution extended far beyond the factory gates. It was a weapon in its own right, one that German strategic planners couldn't counter because they couldn't comprehend it. In late 1943, when German armament minister Albert Speer presented Hitler with the comparative production figures, the strategic endgame became chillingly clear. Germany, at its absolute peak, was producing 540 tanks per month. America was producing 2,100. The 4-to-1 industrial advantage made a German victory a mathematical impossibility in any war of attrition. General Heinz Guderian, the architect of the Blitzkrieg, captured the despair in his diary. Intelligence reports indicate American tank production has increased tenfold within 1 year. If accurate, we cannot destroy tanks faster than they manufacture them. He was right. On the battlefields of Normandy, this industrial disparity became a brutal reality. American armored divisions could sustain losses that would have crippled a German panzer unit, knowing a steady stream of replacement tanks was already crossing the Atlantic. The 2nd SS Panzer Division, Das Reich, for example, entered the Normandy campaign with 89 tanks and received 0 replacements over 3 months of brutal combat. By September, it was effectively annihilated as an armored force, with only 14 functioning tanks remaining. The Sherman tank has often been criticized for its technical inferiority to the heavier German Tiger and Panther tanks. But Sorensen's methods provided a different kind of superiority. The arsenal of democracy proved that in total war, the formula for victory wasn't necessarily the best tank, but the most tanks. The Sherman was good enough, reliable enough, and, most importantly, numerous enough to overwhelm a qualitatively superior but numerically insignificant foe. Charles Sorensen received the Medal for Merit in 1945, the highest civilian decoration. But his true legacy was not a medal. It was the global standard of modern manufacturing. The principles he perfected under the immense pressure of war, continuous flow, waste elimination, synchronized assembly, became the foundation of post-war industrial prosperity. The famed Toyota production system, developed in the 1950s, was heavily influenced by studies of American wartime production, particularly Ford's methods. In the final analysis, Sorensen's impossible trick was about more than just building tanks faster. It was a demonstration of a uniquely American philosophy of war, the application of industrial genius to solve a military problem. He proved that in the modern age, the assembly line could be as decisive as the front line. His battlefield was the factory floor, and his victory was measured in tanks per hour, a victory that provided the material foundation for the Allied triumph and shaped the world we live in today. Thank you for watching to the end. If you liked it, please give it a like, subscribe, and don't forget to hit the bell so you don't miss new videos. There are more amazing stories to come. Take care of yourselves and your loved ones.